We do. Okay, guys, so we are doing acid and base reactions. I know I told you that this was going to be lots of labs in this unit. So instead, Mr. Roy and I are going to do the labs because, well, coronation happened. So, so this is starting on page 18. So we're going to do the lab for you, so you still get the lab experience, which I know isn't quite as cool, but at least you're getting it, right? So it has you doing 3 pre-lab questions about pH, but we're going to walk through the experiments and show you what we're doing, and then you'll be able to write down the results, and then at a later point in time we'll talk about the word problems and the results. So right now we're just going to do the lab stuff. Okay.
Great.
So
nice. So we're going to start with hydrochloric acid first, which we have here. And we need, what do we need? 10 milliliters of that.
Mm-hmm.
And the concentration of this is 1 molar. So I think we've used this before in class.
Yeah.
All right. I'm going to put that in, or are my beakers all the same? No, I'm going to put it in this beaker.
Okay.
Here, I want to hold that for them.
Mm-hmm.
And there's your universal, wait, what do we do first? Oh, litmus paper first.
Yep.
All right, let me get you the litmus paper. Can they see the everything at once? Probably not. But get to see most of it anyway. So here's a red strip. And a blue strip.
Really exciting right there. And there's your blue strip. See what happens to the blue.
All right, here's the universal indicator. Just a couple drips of that. Or lots. All right, and we also have our pH meter over here. This is a probe to measure the pH. So I'm just gonna give it a quick rinse off. It's been in tap water off to the side. I'm dripping all over your stuff here.
Yep, good job.
You're welcome. All right, we'll get that in there. And we'll get your readout. So if you click on the share screen, the green button there. Library Pro. And then share at the bottom corner. All right, so we're running at a pH of 2.46 or so.
I don't need to.
Yeah, probably not.
So for the litmus paper, just indicate what color the litmus paper turned, which hopefully you noticed that the blue litmus paper turned red. And the universal indicator, what color you think that that turned. And here is also this. They can see both, can't they?
No.
They
We
can't
have to
see
go
that
back.
either?
Yeah.
Okay, so we'll just do this one then.
If you go to stop share, then we'll come back. Hi, and then you can go share that other screen. With the, yeah.
So I'm just gonna go back to this.
Yeah.
So make sure you got for the pH meter that you got this for your pH meter for that's was the recorded pH. Okay. And then for the universal indicator,
You click on that and then share there. There it is. Yeah.
these are the colors from pHs of 2 to 10. So just take a look at what you think that most closely resembles for pH.
Great.
Does that make sense? Hopefully. 3, 2, 1, make your decision. Bam.
We're
Okay.
back. So I'm going to set this off to the side because we'll need it later. But that's our acid one.
Right. And then you have to make a conclusion. An acid can be described as, so what you need to say here is, for the acid, the litmus paper turns what color? The universal indicator turned what color? The pH is what kind of pH? What kind of number did you see? So now we're going to take a 10 millimeter sample of hydrochloric acid or sodium hydroxide, which is a base, and test it with a both red and blue litmus paper again.
Wow, I nailed it. Looks the same, right? Doesn't. Very hard to tell what a chemical is, you know, without having it properly labeled.
Litmus paper's over there.
You can taste it though. That's a good way to tell. You know what sodium hydroxide tastes like?
You know, you and Mr. Brown can do that.
Yeah, that's true. That terrified people. Who would have thought the hardest part of this would be just getting the litmus paper out? Do we do? Uh-oh.
Nice job, Roy. Nice job.
Probably just contaminated all of those.
Okay, so that was the red litmus paper right there. And that's the blue litmus paper. So indicate for test 2 how the litmus paper turned color. Indicator. Okay, so now I'm gonna share screen.
Yeah, they can still see that little screen in the corner too. So.
Oh, they can.
Yeah.
So what color do you think that this is? From that pH from 2 to 10. Which one do you think it most resembles?
Great. Now we'll get the pH hopefully. Boy, that is a pretty color though. Looks like Kool-Aid. Do kids still drink Kool-Aid?
I don't know if these kids drink Kool-Aid.
Oops, that's not that. There it is. Okay.
There we go.
All right. So, wow, 14.
We should probably be writing this down.
We can review the footage later. What was it, like 2 point? It was 2.3, I think, for the acid. 14.25. It's going to fluctuate a little bit, but you know, it's around 14.2, 14.3.
Right. Like we're doing it, but
Right.
okay. All right.
Keep that safe over here.
Now we're going to test the tap of water.
Oh wait, I should probably measure 10 milliliters, huh? No surprise, that's tap water.
Oh, and it's got a floaty.
Does it really?
Yes, it does.
All right, let's do this.
This is why we don't drink out of the chemistry sinks.
Yeah, I guess so.
Liam.
Liam. Oh, shout out to Liam. See how safe our drinking water is, right?
Right. Blue litmus paper. Red litmus paper.
Yummy.
And there's our indicator. So what do you think? That most closely resembles.
It's kind of trippy looking in the light, isn't
Yeah,
it?
I know. I'm just wondering if we get like
Oh, that's a good idea.
a piece of paper, maybe. You can kind of see. Here, I'm gonna stop sharing for a second and come back. You can kind of see the color a little bit better. And it's like that. Looks like algae to me. Of course it does.
Of course it looked like algae.
Yeah, I know.
To me, it looks like swamp water,
Mhm.
which I guess is pretty similar, right?
Right. So there's the pH range. What do you think it most closely resembles?
All right, what's our pH look like? This could be scary. Oh, that's terrifying.
Oh, yeah, that's not good.
We may have had some contamination issues here. This does not align with our litmus paper test or the universal indicator test, so might want to throw that data point out.
Did you clean it off with distilled water?
Yeah.
Well, it's going down.
It is going down. Not really fast enough, though. Watch this. We can cheat. They're, of course, seeing this whole process, though, so they're probably going to know that I am cheating. Oh, look at that. I didn't even fix it. I think I froze it now.
Nice, Roy.
It
nice.
doesn't know what it's doing. Yeah. Oh, I didn't hit the stupid key. No, it's just being a pain. I think I broke the program because it's not even changing now. It's stuck. Well,
Of course, our equipment is top of the line.
Oh, yeah.
2020.
Exactly. Well, anyway, use the observation data from the other tests. Don't worry too much about the pH. The program looks frozen. So definitely not 10, I hope, or else.
This is why we do more than one test.
Yeah, exactly. All right, we don't have an unknown, unfortunately, unless we got something kicking around.
I have an unknown.
You do?
Yeah.
I don't even know what it is. Want to give me 10 milliliters of it?
Mm-hmm.
Oh, I'll hide you in the background there.
Hide.
I'll get my litmus paper ready. Sherbinsky, if this is some weird, like, urine sample or something, though,
I don't have a camera with me. Poor child. When he gets to high school, right?
Oh yeah. Oh yeah. I'm sure everyone will forget about all the stories. Usually I steal my unknowns from culinary arts because they have weird, gross leftover stuff from dinners, but the whole school being shut down, there's probably some really gross stuff growing in their lab. Yeah.
One of the very few people.
Ooh, what is that? It's like nuclear waste.
Nuclear waste, probably. Litmus paper.
Litmus paper. I got them right here.
Oh.
Where's that paper? Oh,
Oh, right.
this will be interesting because I don't even know what's going on. Oh, look at that. Okay, that's a clue. All right.
There we
All
go.
right. Your nuclear waste does change the litmus paper.
Yep.
So it's got a color of its own already. What do you think is going to happen if we put universal indicator in there? This could get sloppy. I can't see it. Yuck. Ah, it's got a different tinge to it now.
Mm-hmm. It's like reddish. Kind of hard to tell because it already had a color. Try to see what you think. Are you going to try the pH meter or not?
Yeah, let me see about that program here real quick while we just kind of look at the camera like we don't know what we're doing. Let's see. See if we can boot that up real quick. Where'd you go? All right, it's reading a little weird still, but might be able to get it to work. Let's see. All right, where is our sample?
Okay.
All right, it's dropping. Well, that's a good sign. It's not frozen anymore.
Right.
What is this stuff? It's an unknown. You're gonna have to let us know what you think it is.
Keeps on dropping.
Mm-hmm.
A lot.
Is it gonna stop? That's the question.
Mm.
Well, it was kind of a reddish tint before, so. Probably keep cycling down.
Looks like it's slowing down.
So you guys can't smell this, but I just caught a whiff of the unknown, and I think I know what it is. It smells pretty good, actually. Yeah, let's say 4.2. It's probably somewhere in there. It did slow down quite a bit. I'll rinse this off real good this time. All right, set that off to the side. So we tested acid, base, water, unknown. Now we need to dilute our acid and see how that affects our pH. So I measured 10 milliliters of water earlier so we can mix it together. And might need to add a little more universal indicator, but let's get our litmus paper out first here.
There we go.
Red and blue.
And there's the blue.
I'll add a little more of the universal indicator, see if it, because being diluted, you know, kind of spreads the color out a little bit.
Sometimes it's helpful. Like that. What do you think? For the pH.
I think the meter's gonna work.
Of course, we have faith.
Of course. Well, it's pretty low.
Isn't that lower than it was before?
Yeah, it was lower than it was before. But I did have to turn the program off and back on, so it might be a little
Funny.
weird. Let's say 1.88. Those usually need a 2-point calibration, and we didn't do it that time for sure. All right, so that's the dilute acid test. Now we're gonna dilute our base sample. So, we gotta bring this screen back. So we got the, yeah, we got our base here. We got 10 milliliters. Oops, that's not 10 milliliters. There we go. So now we're doing dilute base. We diluted it by 10 milliliters.
There's the red litmus paper.
Are you starting to, you're writing stuff down? I should probably be doing that too. I'll add a little bit more of the universal indicator just to strengthen the color a little bit. Just a smidge.
There's your color right there. Pick your color.
All right. Test it, see if we can get any useful readings out of this guy. Yeah. What was it before? Just what, 14?
14.25.
Okay.
So dilute it a little bit.
Yeah, 13.25, let's call it, or something like that.
Mm-hmm.
All right. Now the fun part. This is my favorite part. Dang it. Just a little bit too much water in there. We're making a mess. Or I'm making a mess. Ready?
Yep.
Dang it. I was really hoping to get it right. All right, so we just mixed the dilute acid and the dilute base together. And in mixing, you can see the color, hopefully. I want to cheat a little bit. Can we cheat a little bit?
Yep.
Okay. So I'm seeing that it's red looking, right? But if this was a perfect world, it would have come out in between red and blue, which if you looked at the color wheel, who made that acid? It's a little bit strong. Maybe a lot of bit strong. I'm probably going to mess this up completely. I can't even see it.
Lord.
Oh my.
Who made that hydroxide?
I know. Either the hydroxide isn't strong enough or the acid is too strong.
Way too strong.
Oh boy, we're close. Wait. Play by play here. Look at that shade. What is that? Oh. Need like 2 more drips.
We're hitting it. There we go.
There we go. All right. Look at that. Oh no. It's swinging. All right, half a drip. Oop.
There we go.
Oh, wait for it. It'll come back. It'll be fine. Just stir harder.
Just stir harder. Wonder how many times Mr. Brown did this. He's like, oh, I'm not quite feeling it.
Yeah, it's not quite right. That's pretty close.
Mm-hmm.
Let's see what the paper thinks. So red litmus paper and blue litmus paper. That looks pretty good.
Mm-hmm.
All right.
This is what it's supposed to look like. Nice and green. Which would be pH of, oh God, you're killing us here.
It's probably just dropping, right?
Mm-hmm.
Must be a little pocket down there or something. Yeah, let's let that think about it for a minute. You want to get up the color spectrum again? Oops. Yeah, the share button. Wait, this share button. Yeah.
Lord.
I know, it looks obvious, and then it's not. Boy, we nailed it though. Look at that. I feel good about that.
Yeah. After just a little
bit. Just a little bit. Well, we do have amateurs making the solutions here, you know. So a lot of TAs.
Oh yeah, let's blame it on our TAs.
That's usually what I do. I'm not going to name names though. Ashley Childs.
Oh my.
Well, the pH did come down a little bit, but it's not quite where it's supposed to be. But you can hopefully see with the color that we're fairly safe. So.
Right, that's what it should be.
Yeah.
It's in the middle.
The pH is reading 8.76. So it's closer to being in the middle than a 14 and 2 for sure. So, all right. Is that it? I think that's it.
That's it.
All right. So make sure you do the overview and debrief there at the end. Try to make a judgment call what you think the pH scale ranges from, where acids, bases, and water fits on there. And we'll come back with some notes and examples probably later, right?
Yeah.
All right.
All right. Thanks for watching.